Hi, Living Environment. This is Mrs. Kasperwitz, and I'm going to go over the factors affecting enzyme activity with you. We're on pages 9 and 10 in the Unit 3 note packet. So if you have your note packet with you, you can grab that out and you can take notes while you're watching the video. So today we're going to look at what factors or what changes in the environment can be made that might speed up or slow down the rate of an enzyme controlled reaction. So there are four factors that we're going to take a look at. The first factor is temperature, right? So if I change the temperature of the cells in which those enzymes are working, I can speed up or slow down the rate of the reaction. So let's start with this end of the curve. So at colder temperatures, the rate of the reaction is going to go lower because if you recall last week, we said that in order for reactions to go, the molecules have to bump into each other. And the more often we can get the reactants to bump into each other, the more likely the reaction is to occur. So if I increase the temperature of the environment at first, the molecules are going to be able to bump, 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 bump. And the more they bump, the faster the reaction can go. So higher temperatures increase the bumping. More bumping equals more reaction. And so we see that on this side of the curve, right? Eventually, we're going to reach what we call the optimum temperature. This is the temperature at which the reaction has reached its highest point, and it can't get any faster than that, right? That's its best or its optimal temperature. If we go above that temperature, then the enzyme denatures, which essentially means that the enzyme loses its shape, and so the active site doesn't have the correct shape. The reactant or the substrate can't bind, and so the reaction rate stops or slows down. Okay, and so we see this rapid drop off in the rate of the reaction as a result. So in your notes, right, you're going to draw this graph, okay, that shows that in humans, the reaction rate, the optimal temperature is 37 degrees Celsius. Okay, so in your note packet, there is a fill in the blank section. So you're going to fill in the blank where it says the optimal temperature for enzymes in humans is 37 degrees Celsius. You're going to fill in that blank on your notes after you've drawn the graph. And now as the temperature increases, right, so basically this is the word form of what's happening in the graph, okay? So as temperature increases till we get to 37, the rate of the reaction increases, right? But above 37, right, the reaction rate decreases. And we can see that in the graph. We're just putting words to the line, okay? So as temperature goes up, so as temperature increases up to 37 degrees Celsius, the rate of the reaction increased. And if I go above 37 degrees Celsius, the rate of the reaction goes down. Right? So our next factor, the next thing that we could change in the environment is the pH. How acidic or how basic is the environment? So this looks very similar to the temperature curve. All right, we see as we reach the optimal pH, the pH that that enzyme works the best at, the reaction rate is increasing. And then above that, the reaction rate is decreasing. So if we start here at the optimal, the reason the reaction decreases as the temperature or as the pHs get too acidic or too basic is that, again, the shape of that enzyme's active site is altered. And if we alter the shape or change the shape of the enzyme's active site, the reaction can't occur. So we see that below the optimal pH, or above the optimal pH, the reaction rates go down. So again, on your notes, you're going to draw a pH graph for humans. So our optimal pH, the one that we work best at, is around neutral. So you're going to fill in the blanks. So the optimal pH for most of our enzymes in humans is going to be between 6.7 and 7.2, which is right around neutral, pH of 7. So the verbal or the written version of the picture here of the graph is as the pH increases, to 7, the rate of the reaction increases. And then above the pH of 7, the rate of the reaction decreases. So you're filling in the blanks in your notes. But again, all I'm doing when I'm doing this written part is I'm just following the curve, right? So as the pH increased, to 7, the rate of the reaction went up. All right, that makes sense. I can see that there, right? And then above that, the pH or the reaction rate goes down. The next factor, oops, hang on one second there. There we go. So there are some enzymes in the body that work at different pHs. So we talked about this last week. So the enzymes that work best in the stomach, which has an acidic pH, are going to work best in an acid around pH of 2. If I'm an enzyme that's working in the small intestine, then the optimal pH for those enzymes is around 8. So again, different organs in the body can have slightly different pHs, and that will affect the rate of the reaction accordingly. So now you might be wondering why this all happens. So why do enzyme-controlled reactions slow down or stop in high temperatures or extreme pH? And I've mentioned this already, so we're just literally putting it in our notes now, that the enzymes denature. They're proteins. So proteins at high temperatures and at changes in pH are going to lose their shape. And if they lose their shape, they no longer function correctly. So by denaturing the enzyme, by changing its shape, it can no longer bind to the substrate. The active site is the wrong configuration, it's the wrong shape. And so the reaction is going to slow down or stop. So you're going to fill in the blanks then on your note packet where those yellow underlined words are. So here's what that looks like. So here's my normal enzyme. Here's my substrate. This part right here on the enzyme where they're binding is the active site. So when I heat too much or when I change the pH, the active site gets all messed up. The shape of the enzyme has changed. It's denatured. And so this substrate could no longer fit here. And that stops the reaction. So the third factor is substrate concentration. So this is how much reactant I'm adding. So it would make sense that if I have more reactant, right, the molecules are going to be able to bump into the enzyme more frequently. And so the rate of the reaction is going to go up, right? And then when we add a little bit more, we can see that more of the enzyme is reacting. So it's going to be rising, but not quite as fast. And then at high substrate concentration, notice all of the enzymes here are reacting with substrate. That's it. They're working as fast as they possibly can. So even if I keep adding more substrate, the enzyme can't do any more than it already is. They're already all working. And so the reaction rate levels off at a maximum. Okay? So we're going to put that into our notes. Let me get my head out of the way here for a second. All right. So we're going to draw the substrate concentration graph and then fill in the blanks down at the bottom. As the amount of substrate increases, right? So as substrate concentration goes up, the rate of the reaction goes up. And eventually, all of those enzymes are now active. They're all bonded to substrate. They're all doing the maximum amount of reaction they possibly can. And so the rate levels off or stays the same. Okay. If you need to pause and write, you can do that. The last factor is going to be enzyme concentration. And so we can change how much enzyme is available. And it would make sense that if I add more of the catalyst, if I add more of the substance that speeds up the reaction, that the reaction rate would go up, all right, which is what we're seeing in this graph. So if I add more catalyst, if I add more enzyme, the rate of the reaction speeds up. Now you might be wondering why it doesn't level off or why that line just stops where it is. Well, what happens is that there's going to be a point at which all of the substrate is gone. I used it all up. There's no more reactant. And so at that point, the reaction stops. Now it might slow down, like in reality, it might kind of come down a little bit slowly, but it is going to go down because once there's no more substrate, the enzyme has nothing to react with, and the reaction rate is going to fall back down. So those are the four factors that you're responsible for knowing, right? Change in temperature, change in pH, change in the amount of substrate, and change in the amount of enzyme. So I hope this helps. And this goes on pages 9 and 10 in your notepad.